Okay, so we've met natural numbers. So natural numbers are your counting numbers, whether we've really gotten into detail with them. The idea of a natural number is it's the numbers you're used to working with, positive numbers, whole numbers, bigger than zero, starting with one, all the way up to as far as you can possibly think, and then even go further. Okay, so any of those numbers, and we kind of do say our counting numbers, because like 1, 2, 3, 4, and so on and so forth. What we want to do now is extend that further. So if we think about our natural numbers, for which we use the letter n, are kind of like a set within this red circle here, and you have your 1 and 2 and 3 and so on and so forth. What we can do is think of a larger circle which still has all of those numbers, but then goes a step further and looks at negative versions of those numbers. So think about where we might have seen negative numbers before. So things like lifts or temperature or sea level or balances, bank balances and things like that would have negative numbers. And they aren't just numbers with minuses stuck in front of them. They have their own value. They have their own meaning. They mean numbers that are below zero. Okay, kind of opposites of the natural numbers that we're used to. So every natural number is considered to be an integer, but integers also include negative versions of all of those natural numbers as well. So equally kind of, it's one of these cases where the natural numbers, I suppose, is infinite in one direction and the integers is infinite in both directions. So kind of a larger infinite set. So looking at what an integer is defined as, an integer is a positive or negative whole number. So it still has to be a whole number, but it can be positive or negative. We're allowing for both. And the letter we use is the letter Z. So if I was to list it out in set notation, I could pick a few integers in the middle. Usually kind of picking ones around the middle means at least you're showing that you know it's pluses and minuses, and then you're allowing for some dots in either direction to show that you know that it continues on forever. And as I've said, or as we've kind of illustrated to the side there, the natural numbers, that set is a subset of the integers. So every natural number is an integer, so the integers aren't just the negative ones. Every natural number is an integer, but the integers just includes negative numbers as well. And we can use a number line in the same way as we would for natural numbers. We can use a number line to represent our integers. So they go to the left, they go below zero, and as they go to the left, they get smaller. So we move to, I suppose, an interesting idea where if I move to the right, obviously the number 10 is bigger than the number 3. But if I go the other way, the number minus 3 is obviously smaller than the number of 3, and the number minus 10 is smaller again. If you think of it in terms of temperatures, minus 10 is definitely a lower temperature than minus 3. So minus 10 is a smaller number than minus 3 is, because it's more negative, it's further down that number line. Obviously with integers, bringing in a kind of extending our number set, we want to be able to still do our usual operations. And those operations are typically kind of adding and subtracting, multiplying and dividing. Those are the kind of most common operations that we run into. So in order to add or subtract integers, the first thing I would say is to not overcomplicate it. Every number you are used to, like every counting number, every natural number that you are used to, is still an integer. So all of the rules you would normally use need to still apply. So for example, if you were doing 3 plus 4, the answer of course would be 7. What we're maybe extending is that idea that in that case, the 3 and the 4 are positive numbers, and the answer, which is 7, is also a positive number. So if we add two positive numbers, it would seem that we get a positive number. If we're subtracting two numbers, let's say 9 minus 6, the answer of course is 3. And if we're specific about it, it would be a positive 3. The idea here is that the 9, which was the bigger of the two numbers, was positive. So therefore the answer is positive. If we think about it using our number line, if we start at the number 9 and go backwards 6 steps, we end up at the number 3, but still the positive number 3. Okay, so what's coming in here is this idea that we're going to have to decide or construct or come up with the different rules that we use now when we encounter these questions with integers or with negative numbers, I suppose, rather than just positive numbers. And we're maybe even extending our understanding of subtraction to kind of include or encompass the idea of negative numbers. And we kind of get this sense of kind of between addition and subtraction, and when we bring in positives and negatives, it all gets a bit kind of muddled up and can be kind of, in one sense, maybe harder to define the two, but on the other sense, we kind of realize that there's less of a need to. There is a subtle distinction between the two, but it becomes so subtle that it's nearly not worth us kind of stressing about. So what we're going to do is we're going to define some rules. So if we are adding or subtracting integers, if the signs are the same, and what I mean by signs are if it has a plus sign or a minus sign. If the numbers we're working with have the same sign, they're both plus or they're both minus, we are just going to add the two numbers that we have and we're going to keep the sign that they had. So what that might regard, or what that might kind of deal with, is, say, for example, the middle example here, -6 minus 7. They both have the same sign. It's a negative sign, so I know my answer is going to be negative. To work out what it's going to be, I'll just add 6 and 7, so it's 13. So I get -13. That idea that I have a -6, I bring in another 7 negative numbers, so I now have a -13. If you want to think of a kind of actual contextual example, if I was on a lift and I was on floor -6 and I went down 7 more floors, I've gone to floor -13. Okay. The good thing about that rule is that one way of thinking of it is just normal positive numbers. If we're adding two positive numbers like 3 plus 4, the two signs are the same, so our rule says we would add the numbers and keep the sign. So we add them to get 7, keep the sign, which is a plus, so the answer is +7. And that's the same as we had done there. So make sure that if you're confused about the rules, if you think you know what it is, make sure that what you think it is doesn't contradict what you already know about adding two numbers. Now, the different or the kind of trickier one can be when the signs are different. If the signs are different, we keep the sign of the biggest number, so we keep whichever is bigger, so that's going to determine whether the answer is positive or negative, and all we do is we subtract the two numbers. So say we look at the first example here, 3 take away 5. So obviously the signs are different because if a number has no sign in front of it, it actually does have an invisible plus. So I have one positive number here and one negative number. The signs are different, so to decide which sign kind of wins out overall, we go with the bigger number. The bigger number here, of course, is 5, because 5 is bigger than 3, so the answer is going to be negative. To decide what the answer is, we'll just subtract the 2, so 5 take away 3 is 2, so the answer is -2. Another way to think about this is it's like we have 3 green circles. Let's say that the green circles represent positive numbers. We have 5 red circles which represent negative numbers. A positive and a negative number will kind of eat each other nearly. They'll get rid of each other. So all that we're left with is two negative numbers there, or 2 red dots. So we're left with our -2, or 2 negative dots there. Looking at a kind of longer example here, we could maybe gather together positive and negative numbers to make our sum a bit easier. We're just rearranging the numbers. Obviously 6 plus 7, let's follow the rules. The signs are the same. We add the two numbers, keep the sign. They stay positive. Same with the next one, add the two numbers, keep the sign. They were both negative, so keep it negative. And we get an answer of 1. So adding and subtracting can be one of the ones that people find quite tricky, and it just takes a bit of practice and a bit of thinking. So looking through some of these examples here, if we look at the first one, 2 minus 5, I'm expecting the answer to be negative because I have more or a larger negative than I have positive, so I'm expecting a minus answer. And to work out what the answer is, I'll just subtract the two numbers to give me 3. So the answer is -3 or -3. 6 take away 4, well, I know that that answer is 2. It follows the rules though. I need the answer to be positive because the positive number was bigger, and I just subtract the two numbers then. The next one, the signs are the same, so I just add the two numbers, keep the sign that I had. Same on the next one, add the two numbers, keep the sign that I had. For the next one, the signs are different, so we are going to go with the bigger number. We're going to keep that sign, so we're going to keep it as a plus. To work out what the answer is, we'll subtract the two numbers. So 16 take away 11 is 5. So we have +5 left over. So I think that idea that we were using with the dots, that idea that this 11, this -11, cancels out 11 of the positive number that I have, leaving only 5 positive kind of value left, okay, or leaving a +5 left over. So kind of using that in the same sense, I have a +14 but a -3, so I need to get rid of 3 from the positive number, which leaves me with only 11 left on the positive number. Same idea on the next one, I have -12 plus 8. If we follow the rule, we keep the sign of the bigger one and we subtract the two numbers. That should give me -4. If we think about it another way, I have +8, I have -12, so that +8 will cancel out a -8, leaving me with a -4 left over from the -12 there. Okay, so this kind of idea of this adding and subtracting, it can be a little tricky, and it's just really kind of getting to grips with this idea of the rules here. So if the signs are the same, add the two numbers and keep the sign. If the signs are different, we subtract the numbers and keep the sign of the biggest number. So whichever number is bigger has more of a say as to what sign the overall answer has. Okay, and if we think about this dot idea we had at the side, it's that idea that whichever number is bigger will be the one that's left over, that has some values left over. Okay, we've some more questions there with just kind of filling in the blanks really to see what number would go in to make it true. Multiplying and dividing then has slightly different rules that we need to follow, so a different set of rules, but it's all to do with what the end result is going to be. And again here I would say don't forget your normal rules. What we should know about multiplication is if I have 4 times 2, what that really means is I'm adding 2 plus 2 plus 2 plus 2 4 times, which is 8. Or 3 times 4 means I'm adding 4 to itself 3 times, which is 12. So multiplying a number, a positive number by a positive number is always going to give me a positive number. Okay, so let's put this here. So plus by a plus gives me a plus. The next one we're going to look at is what happens when we have, let's use green for the pluses. So a plus by a plus is a plus. What's going to happen when we have a minus by a minus, or a negative by a negative? So we might think about that one. So what happens when we have a negative by a negative? Okay, so a negative by a negative, in the same vein, a negative by a negative is also going to give us a plus. And one of the ways I think about that is nearly the two negatives kind of come together to give us that plus idea, I suppose, to kind of make the plus. That's one simple way of just remembering it nearly. But the main way we're going to remember it is if the signs are the same, you always get a positive answer. It's kind of a positive result. The two signs agree, so we end up with that positive answer in the end. If the signs are different, we are always going to get a negative answer. And where that comes from, I suppose, is the same idea here. If I do a 3 times a -2, that's like me having -2, -2, -2. And we already know from the last section that if I have addition or subtraction where all the signs are the same, I keep the sign and I just add the 3 numbers to get a -6. So the signs were different, but the answer ended up being negative anyway. So if I start with a plus times a minus, I get a minus. And multiplication is one of those operations where no matter what order we do it in, it will work out to be the same answer anyway. So if we start with a plus times a minus, we get a minus, or if we have a minus times a plus, we also still get a minus. So if the signs are the same, we get a positive answer. If the signs are different, we will get a negative answer. So let's go through this. If we look at the first one, the signs are different here, which means I'm going to have a negative answer, and then I just multiply the two numbers to get that answer. Here in the second one, the signs are the same, so I'm going to have a positive answer, and I just multiply them. And usually we wouldn't even put in that plus sign either. On the next one, we're dividing, but it's the same idea. The signs are different, so it's going to be a negative answer. 8 divided by 4 is 2. The next one, let's take it step by step. 2 multiplied by minus 4 is minus 8 times minus 6. A minus by a minus is a plus, so we multiply the two numbers to give me 48. Some extra things to think about with multiplying are the use of brackets. In a lot of the questions, we might see brackets used to represent multiplication. They only represent multiplication if we have two brackets written beside each other with nothing between them. So that's the only time that brackets represent multiplication. If it's literally just two brackets beside each other with nothing in between them, or maybe one number in front of a bracket, that would also mean multiply, but only if there's nothing in between them. And the other case to remember with our negative numbers here in our brackets is if you're presented with a sum like this one, where it's minus in front of a bracket and then a number in the middle of the bracket, that's the same as you having a minus 1. So it's kind of a tricky one where they don't put in the 1 there, but we have to remember that it is there. And a lot of the time we'll maybe get into the habit of nearly not even including that 1. We'll be able to just make that calculation ourselves, that multiplying that minus by the number inside the bracket ends up with a positive number overall. So looking at some more of those examples there, in the first one here, the two signs agree, so the answer will be positive. In the next one, the signs do not agree, so the answer will be negative, and so on and so forth. The signs do not agree, so the answer is negative. The signs do not agree, so the answer is negative. The signs do agree, so the answer is positive, and so on and so forth. Where we see some interesting examples are maybe at the end here, if we remember that squared means to multiply by itself, so minus 3 squared means minus 3 times minus 3. That's a negative by a negative. The signs agree, so that becomes a positive. Minus minus 5, we've already said, is like doing minus 1 times 5, so that's plus 5. Minus 2 cubed, that's minus 2 by minus 2 by minus 2. Sometimes in a case like that where we have negatives especially, they might just put the bracket around that number just to separate them out. But minus 2 by minus 2 is plus 4 times another minus 2, that's minus 8. So interestingly, when the power was 3, the sign remains negative. When the power was 2, the sign actually changed to positive. So I suppose really across all of these questions, what we need to be certain of is going to be the rules. So when we're adding and subtracting numbers or adding and subtracting integers, if the signs are the same, we will add the two numbers and keep the sign. If the signs are different, we subtract the two numbers and keep the biggest sign, the sign on the biggest number. If we're multiplying or dividing them, it's a little bit easier. If the two signs agree, we get a positive answer. If the signs do not agree, we'll get a negative answer. Okay, it really is going to come down to you remembering those rules, and it can be a little tricky. The main one that I find that you really have to remember does end up being the multiplying and dividing. I feel like the adding and subtracting one does come with time, and maybe getting that little kind of conceptual understanding of more of this idea that I was doing to the side here, that idea that positives and negatives will kind of erase each other, or kind of are inverses of each other, so you just end up with whatever's left over and the corresponding sign for that number. And I suppose that comes from that subtraction idea. But essentially you need to know those different rules and operations, think about them as you're doing the sums, really do kind of ingrain those inside your head so that when you come to those trickier examples or you're really being tested on your understanding, that you do have that conceptual understanding. And even just the idea generally of what an integer represents. A negative number, it's a negative or positive whole number, and it kind of represents numbers on both sides of 0 across our number line, continuing in both directions, primarily are only looking at the pole numbers on each direction there, and kind of that idea that the negative number is smaller than the positive number, and making those comparisons and then being able to calculate or carry out those operations.